Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be learning about colligative properties. Our aim for today is how can we describe how solutes affect the properties of solvents. Colligative properties are physical properties of solutions that are affected by only the number of particles, but not by the identity of the dissolved solute particles. What does the word colligative mean? Depending on the collection. We'll be talking about today two different terms: freezing point depression and boiling point elevation. Let's start with a question. Why do we salt icy roads in the winter? I'm sure you've seen this before. It's a cold winter day, it starts snowing or icy raining out, and these big trucks come and dump salt on the roads. What does it do? Why do we do that? Well, let's explore further. This phenomenon is known as freezing point depression. Remember that pure water, H2O, normally freezes at 0 degrees Celsius. So at 0 degrees Celsius, that's when liquid water turns into solid ice. However, when you add sodium chloride, solid NaCl, into that water, the NaCl dissolves and dissociates, breaks up into Na plus and Cl minus ions. By adding that more stuff to the water, it'll cause the freezing point to go lower, below 0 degrees Celsius. In fact, only adding a 10% solution of NaCl would cause the freezing point of water to be negative 6 degrees Celsius. So 6 degrees Celsius lower than the normal freezing point of 0 degrees Celsius. Why is that important? Well, even that small change of 6 degrees Celsius, if the temperature in the winter is below freezing, normal freezing point, below 0 degrees Celsius, but above negative 6 degrees Celsius, so somewhere in that range, the water is going to stay in the liquid form. It is not going to turn to ice. So if it's in the liquid form, not in the solid form, it's able to wash down into the gutter, into the sewer system, and it won't pool up, freeze, and create slippery, icy surfaces. Here's a more formal definition of freezing point depression. Freezing point depression is the difference in temperature between the solution's freezing point and the freezing point of its pure solvent. In our previous example, water, pure water, has a freezing point of 0 degrees Celsius. When we added the salt to the water and created a 10% salt solution, we decreased the freezing point to negative 6 degrees Celsius. So the difference between the pure solvent, which was 0 degrees Celsius, and the solution's freezing point, negative 6 degrees Celsius, 0 minus a negative 6, the difference is 6 degrees Celsius. And that works when we add any non-volatile solute to a solution. It'll cause the solution to freeze at a lower temperature than the pure substance. Here we have a particular brand of ice melt. The brand Green Gobbler Pet Safe Ice Melt, which can be found in your local hardware store, contains magnesium chloride. Now, magnesium chloride, magnesium, in group 2 of the periodic table, has a charge of 2+. Chlorine, in group 17 of the periodic table, has a charge of 1-. When you perform the crisscross drop swap method, you get the formula of Mg1Cl2, solid. When magnesium chloride gets dissolved in water, it dissociates into Mg2+, Cl-, and Cl-. It breaks up into a total of 3 particles. When sodium chloride is dissolved in water, NaCl, it breaks up into Na+ and Cl-, a total of 2 particles. Magnesium chloride is actually a better ingredient for rock salt since it breaks up into more things. Remember, colligative properties only depends on the number of things being dissolved into solution. Since magnesium chloride dissolves into more things, 3, than sodium chloride, which dissolves into 2, magnesium chloride will cause a lower freezing point than sodium chloride. So, using what you just learned, please answer the following question. The question is, which of the 5 compounds will cause the greatest freezing point depression? So, which one of these 5 compounds will have the lowest freezing point? You have choice A, a 1.0 molar solution of NaCl, B, a 1.0 molar solution of CaCl2, C, a 1.0 molar solution of AlCl3, choice D, a 1.0 molar solution of NH4Cl, and choice E, a 1.0 molar of C12H22O11. I'll pause the video here for 30 seconds for you to think about it. Let's take a look at each one of these choices. NaCl, remember, when NaCl is dissolved in water, it dissociates into Na plus and Cl minus. That's a total of 2 particles. When calcium chloride dissolves into solution, it dissociates into Ca2 plus, Cl minus, and Cl minus, a total of 3 particles. For C, AlCl3, it dissociates into Al3 plus, Cl minus, Cl minus, and Cl minus, a total of 1, 2, 3, 4 particles. Now, choice D is a little bit trickier. I see what you're thinking. 1 N, 4 H's, and 1 Cl. So 1 plus 4 plus 1 is a total of 6 particles. That's not the case here. If you look at table E, you notice that NH4 is ammonium. So the charge on that is NH4 plus. So when ammonium chloride dissolves into water, it actually breaks up into NH4 plus and Cl minus. While it has 6 different elements in the compound, it only dissociates into 2 particles. Finally is choice E, C12H22O11. Hopefully that sounds familiar. That is sucrose, table sugar. Now, sucrose is a molecule. It's made of covalent bonds. So this does not dissociate. This stays intact as C12H22O11. So when it dissolves into water, it's only one substance. So to answer the question, which one has the greatest freezing point depression, which of these 5 equal molarity, equal concentration solutions causes the lowest freezing point, the answer will be choice C, because aluminum chloride breaks up into the most things, 4 things. Choice A only breaks up into 2, choice B only breaks up into 3, choice D only breaks up into 2, and finally choice E is only 1. Similarly, we could talk about boiling solutions. Have you ever had to boil something and in the pot you sprinkled a little bit of salt? Maybe you're boiling pasta or vegetables and you add a little bit of sodium chloride, a little bit of table salt to the solution? Well, why'd you do that? The answer has to do with boiling point elevation. Remember, the normal boiling point of pure water is 100 degrees Celsius. However, when you dissolve the sodium chloride, the NaCl, into the water, it once again dissociates into Na plus and Cl minus. Since we have more stuff dissolved in that water, it's going to cause the boiling point to go higher. Now, you're probably not going to add too much salt to your pot of boiling water. So with the amount you are going to add, it's probably only going to raise the boiling point to 101 degrees Celsius. So your normal boiling point, 100 degrees Celsius. Your salt water solution boiling point is 101 degrees Celsius. So, for a formal definition of boiling point elevation is the temperature difference between a solution's boiling point and a pure solvent's boiling point. In the last example, pure water boils at 100 degrees Celsius. When we add the little bit of sodium chloride to the solution, it went up to 101 degrees Celsius, 100 degrees Celsius, 101 degrees Celsius. The difference is 1 degree Celsius. The boiling point elevation is 1 degree Celsius. And of course, the boiling point elevation could be more with the more stuff you add to the solution. Adding a non-volatile solute to a solvent will cause the solution to boil at a higher temperature than the pure substance. Let's use what we just learned to answer the next question. The question is, which of the 5 compounds will cause the greatest boiling point elevation? Which of these 5 will cause the highest boiling point? We have choice A, 0.25 molar NaCl. B, 0.50 molar NaCl. Choice C, 0.75 molar NaCl. Choice D, 1.0 molar NaCl. Or choice E, 1.25 molar NaCl. All these solutions contain the same ionic compound, NaCl, but contain a different amount. The answer is choice E. The 1.25 molar NaCl solution will have the highest boiling point, the greatest boiling point elevation, because it is in the greatest concentration. 1.25 molar is greater than 1.0, 0.75, 0.50, and 0.25 molar. So since 1.25 molar NaCl has the highest concentration, it has more stuff in solution, more dissolved particles, which is going to cause the boiling point to be the highest. In summary, boiling point elevation and freezing point depression depends only upon the amount of solute in solution, not the type of solute in solution. Remember, a 1.0 molar magnesium chloride solution will have a higher boiling point and a lower freezing point than a sodium chloride solution of the same concentration. The reason for that is when magnesium chloride dissolves in water, it breaks apart into 3 particles. When sodium chloride dissolves in water, it only breaks apart into 2 particles. Finally, the greater the concentration of this solution, the higher the boiling point and the lower the freezing point. For example, a 2.0 molar sodium chloride solution will have a higher boiling point and a lower freezing point than a 1.0 molar sodium chloride solution. More stuff dissolved, the higher the boiling point and the lower the freezing point. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we learned about colligative properties, freezing point depression, and boiling point elevation. I hope you can join us again sometime soon. Have a good day.